Okay, we have a monkey. It's always a good sign. Okay, 5 balls, different colored, 5 boxes with different colors that match the colors of the balls. Okay, so the monkey's going to throw the balls into the box randomly. Each box is going to get a ball, but the monkey doesn't know anything about colors. So it's just random shots. All right, so what's the probability that no colors match? And what's the probability that exactly one matches? All right. So this is a quick description of a relatively complicated problem. And I'm going to have to assume that you have some knowledge of basic probability and combinations and things like that. So if this helps, that's good. Otherwise, you might want to consider a lesson. All right, let's first look at a simpler example. So 3 colors. Okay. So this Venn diagram is for 3 sets. All right. So the probability that none of the colors match is 1 minus the probability that at least one matches. Okay. And then the probability of at least one can be written as the union of the 3 sets. Okay, so you might want to pause it here and give that some thought. Now let's look at the union of the 3 sets. So this is known as inclusion-exclusion. Okay, so we add up each individual probability. Okay, keep in mind there's no difference between the colors, right? They're equally probable. Okay, so these are the 3 sets on their own, and we've double counted the intersections, right? So we have to take these away now because of the double counting. Okay, so this is this exclusion. We're subtracting that. And then finally, we added 3 of these, then we took away 3 of these. So then we have to add 1 back in. Otherwise, we'd be missing that. Okay, now let's pause it here and look at the actual numbers. Okay, so each color, the probability that the monkey picks up a ball and throws it in on the initial throw, probability that he gets the right box is 1/3, right? So these are all the same. So we can just do 3 times that. Okay, now for the intersection between 2 sets, we have 3 choose 2. Okay, so these different combinations. The probability of the first throw is 1/3. Now 1 box is full, so the next throw is 1/2. Okay, that's the exclusion. And we need to add back in probability that he gets all 3 right. There's only one way to do that. And the probabilities are like so. All right, now we have to look at 5 colors. And we're going to follow that pattern. Did I write that? It looks like 1, 2, 3, 4, 5, 6. Jeez. Okay, sorry. That's supposed to be. I doubled the P, the purple. Okay, just ignore that. There's supposed to be 5 colors. Okay, so let's look at each piece, the inclusion, exclusion. So we have 5. Again, let me just repeat. There's no difference between the colors, right? The probability of each color, they're all the same. So we can just do 5 times one of them. Then we have to subtract the intersection of 2. We can look at any 2 sets. And we add back in a combination of 3. Remember, this is how many combinations you have. Okay, and then the combination of 4. And it's alternating signs. Finally, we add back in the combination of the intersection of all 5 sets. There's only one way to do that. Okay, so that is the probability of the union of 5 sets. here are the numbers. Okay, so each one is 1 over 5, right? The monkey picks up a ball, throws it in the box. One out of 5 chance he gets it right. 5 different, yeah, it's just 5 times one of those. Okay. Then we have 5 choose 2, which is 10. And so the first box is correct, 1 over 5. Second box correct, 1 over 4. Okay. We add now. 5 choose 3 is 10. First box, second box, third box, minus. Now there's only 5 ways. 5 choose 4 to get 4 combinations out of 5. Probabilities here, 1 box, second box, third box, fourth box. Finally, only one way to do all 5 boxes, and the probabilities are there. All right, it's just a calculation now. So do it on paper and check my numbers, please. Okay, so that's the probability of the union. Remember, we need 1 minus that for the probability of none. So there you go. All right, now the probability of exactly 1. This, you're going to have to pause, I think, and think it over. Probability of exactly 1. Okay, so there's 5 ways to get that. Okay, the first one needs to be right. That's the 1 over 5. And then the next 4 need to have no matches. Okay, so this is like a recursive formula. 5 ways, okay? Each one 1 over 5. And this just simplifies to the probability of getting none when n equals 4. All right. And this is, then we basically, we know the pattern, right? So let's just, it's 1 minus the union, right? So this is the inclusion, exclusion. So this is 4 times each individual probability, 6 times the intersection of 2, 4 times the intersection of 3 minus, that's the problem. That's supposed to be a 2 here. Yeesh. All right. And then just to indicate, there'd be a 1 over 1. That's not right. That's a 2. Sorry. Okay. But anyway, do the work on your own and maybe you'll find other mistakes. That's certainly likely. And so these numbers, are these right? This should be 2 here. This should be 1 over 24. Ish. All right. And I actually fixed it here. Okay, so this is wrong. This is wrong. But then I've got 12 and 4. And this is minus 1 over 24. So it's correct at the end. All right. Okay, anyway, that was pretty quick for a relatively difficult problem, and hopefully it helped.